Here is the combined summary. The paper introduces a novel approach to measure the average temperature of the X component in type II core collapse supernovae by leveraging neutral current incoherent neutrino-Argon interactions in DUNE. By combining spectral information from all active neutrino species with charged current measurements of electron neutrino and electron anti-neutrino fluxes from DUNE and Hyper-Kamiokande, the average X temperature can be inferred to within a factor of 2 for most cases and to 30% for a small range of average X temperatures. The methodology involves modeling the supernova neutrino flux using a Fermi-Dirac spectrum, assuming a 10 solar mass progenitor at 10 kpc from Earth. The neutral current channel's characteristics allow for reconstructing the average X temperature, despite not providing accurate measurements of the neutrino energy spectrum. Flavor nonspecific information from supernovae neutrinos is crucial in understanding the neutrino flux without uncertainties related to neutrino oscillations, matter effects, or neutrino self-interactions. The authors examine the efficacy of constraining NC cross-section uncertainties on improving X measurements, finding that reducing correlated cross-section uncertainties from 15% to 7% would make the size of the 1 sigma allowed regions for TX sample size limited. The analysis utilizes expected neutral current events to measure the average temperature of the neutrino flux, without considering a pinching parameter. The most recently published NC cross-sections from W. Torno et al. Are used, with a 43% theoretical uncertainty. A fractional covariance matrix is constructed to account for the uncertainty in the cross-section, varying with input neutrino temperatures. The detector response and reconstruction efficiency are modeled, with DUNE expecting 15% energy resolution in their TPCs. Efficiency cuts are explored using the distribution of deposited energy per unit distance traveled in the detector to separate NC events from charged current events. Here is a combined summary of pages 58 of the research paper. The research paper presents a novel approach to measuring the average temperature of the non-electron flavor neutrino spectral information from type II core collapse supernovae events using incoherent neutral current interactions in the DUNE FAR detector modules. By combining the expected incoherent NC sample from DUNE FD with constraints on the electron and non-electron flavor temperatures from charged current channel measurements of the DUNE and Hyper-K experiments, the paper utilizes a Binit-log likelihood method to explore the sensitivity of this combined analysis to the X temperature. The results demonstrate that the discrete excitation nature of the NC interaction channel prevents the resolution of the energy spectrum from supernovae neutrinos, but general parameters of the fluence can be measured to the 1 sigma and 2 sigma levels. The paper presents 3 scenarios with different cross-section uncertainties, including a case without cross-section uncertainties, a case with full cross-section uncertainties, and a case with reduced cross-section uncertainties. The combined analysis can measure the average X temperature to within a factor of 2 in most cases, and to within 30% in the best case. The analysis highlights 2 distinct degenerate regions in the measurement space, primarily caused by the discrete gamma-ray energies of the NC cross-section and the uniform fluence across the energy range of the NC events for X temperatures above approximately 8 MeV. Modest improvements to the Argon B, M1, measurements provide substantial improvements to the X temperature sensitivity. The authors discuss the potential of DUNE to measure the average temperature of the supernova nu X component, which is critical for understanding supernovae neutrino emission. By reducing correlated uncertainties, the TX measurement becomes sample size limited, approaching the case where there are no uncertainties on the cross-section. Combining NC measurements of neutrinos on argon with NC measurements of neutrinos on carbon from Juno could provide stronger constraints on average TX temperature reconstruction. The authors acknowledge the importance of prior assumptions on TX, which is critical for deriving credible regions for the average temperature of the supernova nu X component. They demonstrate that a uniform prior on Tx between 0.1 MeV and 300 MeV results in a degenerate region of allowed Tx temperatures, which can bias the expected sensitivities. The expected credible regions for T_X are presented in Figure 12, showcasing the Asimov credible regions as a function of injected T_X values, assuming average neutrino temperatures of T_E equals 3.3 MeV and T_VE equals 4.6 MeV. The uniform T_x prior extends up to 300 MeV, differing from previous credible regions limited to T_x values below 60 MeV. Figure 13 illustrates the fractional width of the 1 sigma credible regions, comparing the width from the hyperbolic tangent prior to the widths obtained from the uniform prior, both below 60 MeV and up to 300 MeV. The three colors in the figure correspond to the three cases of cross-section uncertainties: 40% uncorrelated and 15% correlated uncertainties, 40% uncorrelated and 7% correlated uncertainties, and no uncertainties on the NC cross-section. The results demonstrate the impact of prior choices on the credible regions, with the uniform prior yielding broader credible regions due to its wider range. The fractional width of the credible regions increases with the injected T_x value, emphasizing the importance of accounting for uncertainties in the cross-section. The comparison between the hyperbolic tangent and uniform priors reveals that the latter yields more conservative estimates of the T_x credible regions. The choice of prior and uncertainty treatment significantly affects the inferred T_x values, underscoring the need for careful consideration of these factors in future analyses. The assumption of a uniform prior up to 300 MeV allows for a more comprehensive exploration of the T_x parameter space, but may also introduce additional uncertainties. The findings highlight the importance of accounting for prior choices and uncertainty treatment in the analysis of T_x values.